Let's talk about synthetic division. So synthetic division is a shortcut for the process of polynomial long division. Takes up a lot less space, so you don't have to write out as much, but it can only be used in certain contexts. So when specifically we're dividing by a binomial of the form x minus c. So in other words, x plus a number or x minus a number, but we're going to grab the opposite sign. So similar to the relation between a factor and it's zero, what would make that divisor equal zero? That's the number that we're going to use. By taking that opposite sign, we're already kind of applying the subtraction. So we're shortcutting the division step because that leading term, all that's going to do when we divide by the leading term is reduce the term down to the next lower power of x. And then by using the positive c rather than the negative c, we combine the multiplication and subtraction. So we're going to have a multiplication and addition steps repeated in the process. So the first step in the process is just determining the value of c. So what's being subtracted from x. Then we're going to write the coefficients of the polynomial inside the division bar, but we need to include zeros for any missing terms. Then we drop the first coefficient down as is, and then we have the multiplication and addition repeated process. So looking at this example, we have 2x cubed minus x squared plus 3, and it's being divided by x minus 3. So c, what's being subtracted from x, is 3. So we're going to use a positive 3. And then we write the coefficients, and we have an x cubed, x squared. We're missing an x term. So when we write the coefficients, it's like if I said that I have a number that is 2 times 10 cubed plus 5 times 10 plus 7. All right, if you wanted to write that as a regular number, the 10 cubed is the 1,000, so you'd have 2,000, and we just write 2. And then, but we don't have a multiple of 10 squared, so we write 0 in the hundreds place, and then 5 times 10 would be a 5 in the tens place, and then the 7 is really 10 to the 1 and 10 to the 0. So back when you were learning place values, you might have even had pictures where they used maybe sort of a cube symbol to represent thousands, and a grid for the hundreds, and sticks for the tens, and the little square for the ones. But if you just had hundreds or thousands and tens and ones, you would have to put in a 0 for the hundreds place. So that's kind of what we're doing here. We're writing this polynomial just by its coefficients, but we have to kind of have those placeholders so that as I'm looking at this, I know what power of x each of those coefficients corresponds to by its position. Of course, unlike decimal numbers, we can have a negative. They're just, we don't have a limit, so I could have a coefficient larger than 10. So there are a few differences between just decimal place values, but the filling with a 0 is similar. So the 2 just drops down as is, and then we start the multiplication and addition process. So the 2 gets multiplied by 3 to get 6. That gets added, then -1 plus 6 is 5. And then we repeat. 5 times 3 is 15. 0 plus 15 is 15. 15 times 3 is 45. 3 plus 45 is 48. So then the quotient is everything but the last one become the coefficients on a 1 lower. So we had x cubed, now we're down to x squared. So the quotient is 2x squared plus 5x plus 15. And then the 48 is the remainder. Right, so let's do this process a couple more times. So x cubed minus 4x squared minus 5 divided by x minus 3. So I put a positive 3. Because I'm looking again, what would make that divisor 0? And then the coefficients, I have 1 for the x cubed, minus 4 for x squared. There's no x, so I put a 0. And then there's the minus 5 for the constant term. So there's my coefficients. And then the actual division process. So the 1 drops down as is, and then I have the multiplication. So times 3, 1 times 3 is 3. Negative 4 plus 3 is negative 1. Negative 1 times 3 is negative 3. 0 plus negative 3 is negative 3. Negative 3 times 3 is negative 9. Negative 5 plus negative 9 is negative 14. Now, you don't have to write out the multiplication and addition there as you do it, but I'm just marking it and saying it so that I follow where those numbers are coming from. But this means then that the quotient has coefficients of 1, negative 1, and negative 3, and it's going to be 1 lower degree, so it's x squared. So x squared minus x minus 3. That's what the 1, negative 1, and 3 mean. And then the negative 14 is the remainder. All right, and then the next example says, show that x plus 3 is a factor of this whole polynomial. But what that means is it's going to have remainder 0. So if I do the division and get a remainder 0, that shows that it's a factor. So I'm going to write, in this case now, c is negative 3. So I write the negative 3. And let's see, what do I have? 5, 4, 3, 2, 1, 0. So I don't need to fill in any 0 placeholders. I just write all the coefficients. 2, 5, negative 2, 2, negative 2, 3. Leave myself some space, and I'm going to drop the first one down as is, and then I do the multiply and add. 2 times negative 3 is negative 6. 5 plus negative 6 is negative 1. Negative 1 times negative 3 is 3. Negative 2 plus 3 is 1. 1 times negative 3 is negative 3. 2 plus negative 3 is negative 1. Negative 1 times negative 3 is 3. Negative 2 plus 3 is 1. 1 times a negative 3 is negative 3. 3 plus negative 3 is 0. That remainder 0 means it divided evenly. All these guys, these results are the coefficients on the quotient, and it's going to be 1 lower down. So we have 2x to the 4th, and then minus x cubed plus x squared minus x plus 1. And what this tells me is that that result multiplied by x plus 3, like that's a way to rewrite and actually partially factor 2x to the 5th plus 5x to the 4th minus 2x cubed plus 2x squared minus 2x plus 3. So this has now been partially factored by doing the synthetic division, seeing that the remainder comes out 0. But that's synthetic division.